Welcome to the summary video of the workshop I've just finished running, a 90+ minute workshop about sequences. Not the basic stuff about sequences, but looking a bit underneath the surface and seeing what makes a sequence. Now, I'm not going to cover the entire workshop. This is meant as a summary, so I'll try to keep it short, of what we've covered in the 90+ minutes. It's useful for those of you who have been in the workshop as a refresher, but also those who maybe were signed up and couldn't make it. This gives you a taste, a general idea, a brief summary of what went on. So I will be quick in this video because I don't want a 90-minute video, right? I want to be a short summary. So we're discussing sequences, and we are familiar with sequences. Let's refresh the console there. That's the last thing I had running in the session. We know things like numbers, for example. Let's create there a list. A list is a sequence. We'll see what the sequence means in a bit. Strings are sequences as well. We have tuples. I'm not going to go through them all. We have things like range. Let's say some range is also a sequence. For example, let's say from 3 to 15. These are all sequences. Now, what makes them sequences? There are many of these words: sequence, collection, container, iterable. And sometimes they can easily be confusing because there's a lot of overlap between many of them. So a sequence, there are 3 bare minimum requirements for an object to be a sequence. The first one, it needs to have a defined length. So all of these, I can find their length. And you might think, well, so what? That doesn't sound very exciting, right? But not every object has a defined length. So a sequence must have a defined length. And the same applies for range, by the way. So range, that's 12. From 3 inclusive up to 15 exclusive. That's 12 numbers. So condition 1, for it to be a sequence, it must have a defined length. That's not enough, however. It must also be iterable, which means you can iterate through it. I've replaced an iter word with another iter word. Iterable means I can use it in a for loop. I can use it in anywhere when I need to fetch each item of the object in some sort of one after the other. So for example, I could use a for loop for stuff in, pick any of them, name, print, stuff. And that works. And if I replace name with numbers, it's going to work. With some range, it's going to work. In fact, with anything that's a sequence, is also iterable. That's 2 out of 3. But in order for it to be a sequence, we need to meet all 3 of these requirements. So let's look at the third one. The third one, for an object to be a sequence, is that we need to be able to index it with an integer that represents the position of the item. So for example, if I say numbers, square brackets 3, 0, 1, 2, 3, that should give me the 4th item from the list. So I'm using an integer that represents the position. The same applies for all sequences. So name 2 is the 3rd item in Stephen, which is the E. I can also do it with range. What's the 5th value? We're starting from 3, 4, 5, 6, 7. So all of these list, string, range, there are others, right? Tuple and more. If they meet these 3 minimum requirements, then we can treat them as sequences. Now, often some people say, there's more, however, but we can also put slices there. And that is true for most sequences, but it's not a requirement for you to be able to slice. Most sequences can be sliced, but it's not a requirement. And I'll show you an example. So for example, from collections, let me create some. Now, if you're not familiar with the DAC data type, don't worry. I've got an article about it if you want to go and read it, but it's similar to a list. That's all we need to know in this case. And I'm going to create it. So collections.dac. So this is not a built-in, it's from the standard library, so from the collections module. And I'm going to convert numbers. So I'm going to convert the list numbers into a DAC. Not some range, some DAC. There, it looks like a list, it behaves similar to a list. There are important differences, but because of how a DAC is optimized, it's optimized to be able to get items from the beginning and from the end. So it's different than a list. we cannot slice. So if I say, give me the slice from the beginning up to and excluding item 3, that's range. Sorry, it did work. That's because I put some range there. I meant to put some dec. And this doesn't work. It says sequence index must be integer, not slice. In this case, it's specific for the dec. We know that other sequences, in fact, you've seen that some range works, but also if I use numbers here, which is the equivalent list, it also works. So some dec is a sequence. I'll let you try it out, check that it has a length. You can iterate through it, and you can fetch, let me show you just the last one, right? If I say, give me the 4th item in the dec, I get it. So I can index it with an integer. I cannot slice. So those are the 3 main requirements. Now, having said that, not all, all sequences meet these requirements, but most sequences, I would say almost all of them, meet a higher set of requirements. Let's have a look. And let's go for numbers first. Now, when you look at numbers, and you've probably used lists many times, so you're used to, if not all of these methods, many of them. So index to fetch, for example, I want to find what's the index of 5 and 3, 4, 5, so the index is 2. So this is going to tell me it's in position 2, if I can press enter. Good. And append, count, extend, insert, clear, copy, pop, remove. Maybe you've used all of them. Maybe you're familiar with many of them. Let's look at the dec now. My dot, or not my dec, what do I call it? Some dec. Notice how there are similarly named methods: index, append, extend, count, insert. Then there are others. Append left exists in the dec, but not in the list. So they're not identical, but many of them, clear, copy. Many of them are similar. Copy, in fact, is not specific for what I'm looking at here. Pop, remove, reverse. And we will find these in other sequences as well. Not all of them. For example, strings won't have these, but you will find index and count. You won't find the others. These are all string-specific ones, but index and count, we've seen them with lists, we've seen them with decs. In fact, index and count will be in almost every sequence, even though they are not the requirements we talked about. Okay, we'll come back to this. Let me show you an example. Now, what I'm not going to do in this summary, I'm not going to go through the example, the specific example I went to in the live lesson. That was a bit of a long example. We had plenty of time to deal with it. For 2 reasons. First of all, I want to show you something more brief and more succinct. But also, the example I showed in the live lesson was from an article I wrote a few weeks ago. It's actually an article I published on the Real Python website. So what I'll do is I'll link to it. I'll give you that link so that if you want to look at that article, at that example in detail, rather than through a long video, you can look at it through a written article. So what I'm going to do here, I'm going to look at a simpler example, and I'm going to create my own custom sequence. And in this case, I'm simply going to call it my sequence. Right? And in the workshop, we used a real example where we had an application and had context. In this case, I'm simply going to create a basic sequence. So class my sequence, and just to keep it nice and simple, let's assume we have an init method that accepts some data, and we're going to store this data. And let's say that data is going to be some iterable, and we're going to convert it to a list. So that we know with certainty that self.data, so the data attribute attached to the instance, is whatever we pass when we create this instance. It might be a list, but it might be a tuple, it might be a string, it might be some other iterable. We're going to convert it to a list. Now, in this case, we're not going to worry about changing the functionality of this. We just want to create a class, but we also want to make sure it's a sequence. But do have a look at the example that I'll link to, so that you can see a sort of, not necessarily a real world example, but an example that has some context. Okay, so that's enough to create a class, but the question is this a sequence? Is it enough for me to call it my sequence to make it a sequence? You probably know the answer of that. So let's create stuff, and let's create my sequence, and I need to give it, there we go. Okay, so 3 requirements. The first one, can I find the length? Len stuff. This is one of the 3 basic requirements to have a sequence. Let's find out. No. Object of type my sequence has no len. So we already know it's not a sequence because all 3 of those conditions must be met. But let's keep going. Let's find the others. So length doesn't work. We've already failed 1 out of 3. Let us try to print the second item from stuff, square brackets 1. My sequence object is not subscriptable. We failed the second test. We cannot fetch an item using an integer that represents the position. I was hoping for 6 to come out, but Python doesn't know that. So we failed the second one. Is it iterable? For item in stuff, print item. If it's iterable, this will give me the items. If it's not, it's going to tell me my sequence object is not iterable. So we failed all of them. But this also tells us that in order to make this object, this class, create objects that are sequences, I need to somehow give it these 3 characteristics. Let me start with this last one. No, sorry, not this last one. Let me start with the previous one. I want to be able to, this is in some ways the defining characteristic of a sequence, right? I need to be able to fetch an item based on the order in which it's in the sequence, using an index. 1 represents the second item. Now, the square bracket notation, in order to create, give an object that functionality, I need to define one of the special methods, specifically the dunder get item. Let's call this index because we're defining a sequence. So this index is whatever number we put in square brackets. So the square bracket notation is calling get item, and whatever I put in the square brackets is index. Good. What do I want this get item to do? Well, if all I wanted to do is deal with that list, in this case, this is a simple example. I'm going to take self.data, which is a list. I know it's a list. I made sure of that. I can use the square brackets on a list. So I'm saying stuff square brackets 1 is the same as stuff.data square brackets 1. I told you this example is not interesting, right? But you might have more interesting examples if you're trying to do something a bit different. If we run this, that works. I have been able to extract the second item using stuff1. So I have made my object indexable. 1 out of 3. How about len? This doesn't work, right? What's len stuff? Still the same problem. For this, I need another dunder method, another special method, the dunder len. And this should return the length. And once again, because I know that I have the data attribute data, which is a list, all I need to do is work out the len of the list. Len works on a list and self.data is a list. So now the length of stuff is 4. So I've dealt with 2 of the 3 requirements. However, I've actually also dealt with the third one without realizing it in some ways. Let's confirm that. For item in stuff, print item. And this works. So we have also made our object iterable. This means it ticks all 3 boxes. This is now a sequence. Now, however, when we want an object that's iterable, we have the old way of doing this and the new way. The old way uses getItem. That's why this works, because getItem is enough to make an object iterable. But we prefer these days to also define iter. So even though it's not needed to make a sequence, we'd rather do it. And iter is going to simply return convert self.data into an iterator. That's what iter needs. I talked about iteration in a previous workshop, so you can see the summary of that one. So this is great. This creates a sequence, but this is the bare minimum. So for example, if I say here stuff dot, you can see that I have data, which is the data attribute, lots of dunder methods, but nothing else. There is no count, for example. You know how we've seen that count and index, every sequence we've seen, including strings, had a dot count or a dot index. And then with lists and dec, for example, we also saw that there are dot pop and dot append. Do we have to define them all? No. Luckily, we don't have to. So instead of doing it this way, we could, and I'm going to comment these out for now, from collections.abc, I want to import an abstract base class called sequence. There's another one called mutable sequence, which we discussed in the workshop. I won't discuss here, except for very briefly at the end, but let's stick with sequence for now. And I'm going to define my sequence so it inherits, it's built on top of this abstract base class. Now, let's start, all I have is the init there. Let's run this code. It doesn't work. And it says, the bare minimum I need is get item and len. We've seen this already, right? These are the bare minimum requirements. So let's put those bare minimum requirements. I could put iter as well, right? But let's leave them. And now it works, no errors. So I've been able to create this. And just as before, I'd be able to fetch an item using the square brackets, iterate through it, and find its length. Now I'm going to put the iter back in because we prefer in modern Python, we'd rather have the iter method. And you might say, well, okay, isn't this the same as before? You know, you've just added a bit of inheritance, but you still have the same methods that you had before. True, but notice what happens when I say stuff dot. I now have index and count. Remember these methods that we've seen them in every sequence, strings, lists, tuples will have them. Every sequence you can find, you'll find that they will have index and count. Not because they form part of the bare minimum definition, but because most sequences in Python, in fact almost all of them, they effectively inherit from this abstract base class, which has count. So now, without me doing anything, I can say, what's the index of 7? I need to print it out. Oops. What did I do there? Print. And it works. Index of 7 is 2, 0, 1, 2. A reminder that if I did not inherit as I did before, this wouldn't work. It's going to say my object, my sequence object has no attribute index. Of course it doesn't. I didn't define it there. But when I inherit from sequence, some things come with it, such as index and count. So I can count how many times does 7 appear? Once. So the sequence abstract base class not only ensures that I have to define the bare minimum. You may remember when I didn't have get item and len, it said no, I can't do that. So it's ensuring that you define the bare minimum you need, but it's also giving you a bit of extra, a bit of bonus. So I've more or less covered the general idea of what we're discussing, but I promised you I'll also show you mutable sequence. So mutable sequence goes beyond sequence. Sequence was an immutable sequence, so we couldn't make any changes. In fact, you can see that none of these methods, including index and count, they don't change the object. They just fetch information about it. Mutable sequence is different. Now, let's run this and see what errors we're going to get. Now it's telling us, if this is a mutable sequence, I also need, at the very least, 3 more methods. Delete item to define how to delete an item, set item, and insert. So you'd have to go and define those. I'll simply show you again. In this case, this is not too difficult, right? Because we're simply not delete item. That's the one I want. We can call this index because it's a sequence. This is what you do when you say del stuff square bracket 0, for example. And in this case, this is not too difficult because all we have to do is say delete self.data index. So once again, I'm using the fact that data, self.data is a list, and therefore I can delete it because it's already a sequence. And in fact, let's do them all quickly. Set item is the same. Let's call that index because I prefer to do it that way, but you can keep it key if you want. Not delete. So here we want to take self.data, which is a list. Therefore, I can say square brackets index, fetch this particular value and replace it with value. And finally, insert. Insert, for those of you who are not familiar, means you can put an index. For example, you say in position index 2, I want to insert this value, and it pushes the rest of the values further up. And in this case, once again, I can rely on the fact that self.data is a list, so I can insert index value. So these are not very interesting, but I didn't want to do that. These are not very interesting methods. I'm simply relying on the fact that the only attribute I have here is a list. So my sequence doesn't do anything that the list doesn't do, right? But just as an example. And now it works. And this means that I can also, for example, which I couldn't do before, I can now change the value of one of the items. For example, stuff 2 is now equal to 99. You can try this before when you were inheriting from sequence, not mutable sequence, and you didn't have these three methods. This wouldn't work. But in this case, this will work. Let me print stuff.data 46992. Good. And now, if you look at stuff, what methods does it have? It has data, index, and count. We've seen them before, but now it has append. You're used to this from lists. It has extend, clear, pop, remove, reverse. So these are methods that, even though they're not strictly speaking necessary for a sequence, but every mutable sequence, if you define it using this abstract base class, will share these methods. So if you want to create a sequence, your best route is to use these abstract base classes. And then if any of them, these are the default values, right? So append is going to do what you expect it to do. For example, if I append 500 and then print stuff.data, you can guess what's going to happen. The 500 is going to go there, added. But if you have a specific requirement in your sequence and you want append to do something a bit different to fit your requirement, then you can go and define it as well. So you can still define your own version of append, and this will overwrite the default. But you don't need to. If you're happy with the default value, then the abstract base classes sequence and mutable. Sequence doesn't give you append, but mutable sequence does. Those are sequences. So now, hopefully, whenever you come across sequences, you can see the similarities between them. And depending whether they are immutable sequences, in which case they only have a couple of methods that come with it, or mutable sequences, then you'll be able to use the fact that there are these similarities between them, even if you never need to write your own user-defined sequence. We'll stop there.